This is lesson 8.4. You should be on page 512. This lesson is called Use Scientific Notation. Numbers like 1,000,000, 153,000, and 9/10,000ths are written in standard form. Now, standard form also can be called written as a decimal. Those are all written as decimals. Just to be clear, sometimes people are like, well, wait a minute, I don't see a decimal in the number 1,000,000. You're correct, you don't, but it's there, it's after the zero. That number is written as a decimal. Or 153,000, there is a decimal at the end, we just typically don't write it down. So standard form is also written as a decimal. However, another way to write a number is to use scientific notation. Scientific notation is when you write a number in the form c times 10 to the nth power, where c would be a number that's at least 1 but less than 10, and n is an integer. Now let's review these vocabulary here. Integer means the variable must be a whole amount. It can't be fractional or decimal. Like I couldn't have a power of -1/2 in scientific notation. Half isn't an integer. Okay, I could have positive whole amounts, 1, 2, 3, 4, 5, 6, 7, 8, or I could have the negatives of those and so on. Okay? Now, why do we use scientific notation? This might be an example. 2,000,000 is a big number. It might be easier for me to write it as 2 times 10 to the 6th. Or here might be a better example. Take the number 15 trillion. It would be a lot more convenient for me to write that as 1.5 times 10 to the 13th power. It's just easier to write. When I have extremely long numbers, either super large or super small, it's easier to write those large, long numbers in scientific notation. Okay? I can also write little numbers in scientific notation that are long. Now here would be an example of the number 5,000ths. I could write that as 5 times 10 to the -3rd. A better example might be something like this. You know, a super long, tiny number like this, I could write in scientific notation much easier as 8 times 10 to the -15. So when you get long numbers that are either super large or super tiny, scientific notation is a great way to write these in a much quicker way. Now, to use scientific notation, to write a number in scientific notation, it's a 3-step process. Here's the first step. Move the decimal to create a number between 1 and 10. Then, after that, you write times 10. And then the power of 10 represents how many places you would have to move your decimal to get it back where it was in standard form. You might want to pause the video real quick and just write those 3 steps down. Okay, so now let's look at those 3 steps in these examples. Okay, so we have the number, there's a pretty big number, 42,590,000. Step 1 is move the decimal to create a number between 1 and 10. So you notice the decimal starts here, but they're moving it in between the 4 and the 2. So now we have 4.259, so there's step 1. I move the decimal. Step 2, write times 10, which you see they did here. And then step 3, now you know, I have to, if I want to write my exponent, it should match how many places I would have to move the decimal to get it back where it was. Let me count. I'd have to go 1, 2, 3, 4, 5, 6, 7 places to get it back where it was. That's why I have 7th power. So this number is 4.259 times 10 to the 7th power in scientific notation. Now here's a small number. Same step. Step 1, move the decimal to create a number between 1 and 10. I did, 5.74. Step 2, I wrote times 10. Step 3, let me use a blue pen so it shows up better. To get my exponent, I would have to move my decimal 1, 2, 3, 4, 5 places to the left to get it back where it was. That's why I have a negative fifth power. There is my number in scientific notation. Now you notice, if it's a large number, you'll have a positive exponent. When it's the tiny decimal numbers, you will get a negative exponent. Now, sometimes they will ask you to, in the book, they will ask you to do the following also. They will say, take a number in scientific notation and change it back into standard form. Okay, that's pretty easy to do. You take your, here's the number in scientific notation, right there. Okay, to write this in standard form, the sixth power means take your decimal and go 1, 2, 3, 4, 5, 6 places back. And since these last 2 places didn't have numbers, we put zeros in there, which you can see here. And that would, this scientific notation number is the number 2,007,500. Here's a tiny number in scientific notation. To write the actual number, I would take negative fourth power, which means take my decimal and go 1, 2, 3, 4 over, and put a decimal. Now I have three spots here with no numbers. I'll put zeros in those. So I'll have 0.0001685, which is what you see here. There is the standard form number for the scientific notation number 1.685 times 10 to the negative fourth. Another thing they're going to ask you to do in this lesson is order numbers from least to greatest. Okay, so here are 3 numbers, 103,400,000, 7.8 times 10 to the 8th, and 80,760,000. I want to order these from least to greatest. The first thing you can do is, I like doing this, I like putting each number in scientific notation. So you notice this number, if I rewrite it in scientific notation, I get this. And then this number, if I write it in scientific notation, I get that. Okay? Now, next, order the numbers. Now, here's an important part. The power of 10 is the first thing to look at. First, order the numbers with different powers of 10. Okay? Now, you might be like, what do you mean? Okay? Here's what I mean. I've had people that have screwed up the following. I'm going to pick something easy. I've had people that have messed up the following. Okay? Let's order 9 times 10 to the second and 2.3 times 10 to the fifth. Okay, let's think about this for a minute. Doesn't this number mean 900? And doesn't this number mean, wow, 230,000? Well, I think when you look at those, it's obvious to you watching the video that 230,000 is way bigger than 900, right? However, I've had students that when they write out answers to this, wrote this number that I'm highlighting in blue first because they saw 9 and they said 9 was bigger than 2.3, and since 9's bigger than 2.3, this number's bigger. No, that's not right. What I'm showing you here in what I highlighted in blue is we have to look at the powers first because these tell us which number's bigger. Think about it. 10 to the fifth is 100,000. 10 to the second is 100. 100,000s are way bigger than hundreds. Okay? So when I look at these numbers now, let me highlight them all in, we'll do yellow. Okay? I want to order these numbers. Can you see how this number that I'm circling has to be the smallest because it has the smallest number power of 10. This only has 7th power. These have 8th. So 8.076 times 10 to the 7th should be the smallest number. Now, do you notice the next two number, we have a tie. They both have power of 8. Now, to break the tie, then you do look at the number in front. So the next number would be the 1.034 times 10 to the 8th. And the biggest number in the group is the 7.8. Let me erase this stuff here. The 7.8 times 10 to the 8th would be the biggest number in the group, which is matching what the book wrote here. You have to look at the power of 10 to determine the order of least to greatest in scientific notation. The power of 10 is the big thing. The number in front breaks the ties. Okay, another thing you're going to be doing. Well, actually, let's try one here. Pause the video and try this. Okay, we're back. We should say this number is 2.75 times 10 to the 4th. So can you see these two have to be the smallest? They have 4th power. So I'm just going to label them. This number is the smallest because 2.75 is less than 3.401. This number would be in the middle, and this is definitely the biggest number because it has the biggest exponent, 5th power. We also have to compute numbers in scientific notation. I normally have you do a few non-calculator problems over this on quizzes and tests. And the examples they put here have a bunch of decimals, and I normally don't give you those kind with no calculator. So here would be a good example of a no calculator computing numbers in scientific notation. It's really easy to do. Here's all you have to do. I'm going to color code it. Okay? You take these two numbers. Now, maybe I should say this first. Do you notice? We have multiplication, we're multiplying, and we're multiplying. That means I can arrange this in any order I want. So I'm going to take these two numbers, and I'll put those together first. And I'll take my two base 10 numbers, and I'll organize those after. And now this should be really easy. I have 3 times 2 is 6 times, remember, if you have the same base, you can add the exponents. This would be 6 times 10 to the 8th power. That's all you have to do on a problem like that. Shouldn't need a calculator to do a basic one like that. Okay? What about this? Okay, again, I won't use the book example that has decimals. Let's use this one. I want to square 4 times 10 to the negative 3rd power. So remember, this is the power of a product. You need to square the 4, and you should also square the 10 to the negative 3rd power. Well, I'd get 16 times 10 to the negative 6th. I want to write this in scientific notation. This is telling me to take my decimal and move it 6 places back to the left. Now, do you notice this is not in scientific notation right now? I don't have a number between 1 and 10. So let's move the decimal. Now remember, this is saying move the decimal 6 left. I'm going to move it one of those 6. I'll put it here, which means I'd still have to move it 5 more times. So I'm going to change this to 1.6 times 10 to the negative 5th. That would be the correct answer to this statement in scientific notation. Okay? Let's do one more. I got to get this stuff off of here. Okay, here's one more. A division. Okay? I can write this as, I can break this up. I have 8 over 4 times 10 to the 4th over 10 to the negative 3rd. Now, remember, 8 over 4 will be 2. Over here, do you notice how I have the same base? And I'm dividing. I can subtract the exponents. 4 minus negative 3 is 7. So this would work out, this statement would work out to 2 times 10 to the 7th power. Should be easy for you to do some basic scientific notation calculation without a calculator if I'm not giving you a bunch of decimal problems, which if I had you do no calculator on a quiz or test, that's what I would do. And then the final thing, I will have some word problems. It's the same stuff, it's just worded like here. Blood flow is partially controlled by the cross-sectional area of a blood vessel through which the blood's traveling. 3 types of blood vessels are venules, capillaries, and I want to say arteries, but arterioles. I haven't had that in a while. Arterioles, biology. Let's keep going. So let R1 be the radius of a venule, while R2 is the radius of a capillary. Okay, so here's venule, and here's capillary. Find the ratio of R1 to R2. So R1 over R2. R1 is the venule, which is 1.0 times 10 to the negative second, and R2 is the capillary, which is 5.0 times 10 to the negative third. So what I just showed you in the previous slide, I'd have 1 over 5 times 10 to the negative second over 10 to the negative third. 1 over 5 is 0.2 times, here I have the same base. Do you notice the same base? I should be able to subtract. Negative 2 minus negative 3 is positive 1. Now this is not written in scientific notation though. Okay? So the 1 power means I have to move this 1 to the right. Well, if I put the 2 with the point after it, I would have 10 to the 0 power now, which is the same as 2. And that's what's matching here. So this is saying a venule is twice the size radius, or the radius of a venule is twice that of a capillary. So they will have some word problems where they will ask you to use some scientific notation calculations with them. I think I'm going to pause the video here. If you have any questions, make sure you ask during class.